Welcome back, Physics 30. This is the last part of the Unit 3 booklet. So in the previous video I mentioned the kilowatt hour unit used for very large power usages such as your bigger appliances like washer and dryers. The relationship between a kilowatt hour and a joule is 1 kilowatt hour is 3.6 times 10 to the 6 joules. So if we look at a question here, how much work in kilowatt hours, so remember that's a unit of work, watts, seconds, or kilowatt hours, because you have power times time, is done by a 6.0 times 10 to the 3 watt electric generator running 8 hours a day for a year. So 8 hours a day, 8 hours times 365, that's a total of 2,920 hours. So power equals work over time, or work is equal to power times time. We have 6. Now 6,000 watts would be 6 kilowatts. So here either use units of watt seconds or kilowatt hours. So since it asked for kilowatt hours, I had to change watts to kilowatts by dividing by 1,000 and then finding the total hours. So it works out to be 17,520 kilowatt hours. I have 2 sig figs in all my numbers, so that rounds off to be 18,000 kilowatt hours. B, how long in hours will it take a 500 watt power drill to do 100 kilowatt hours of work? So I have kilowatts, I have watts, so this has to be changed into kilowatts. So 1 kilowatt is 1,000 watts, just like up in the previous question. So I'm looking for time in this question. I know what power is, I know what work is, so interchange T and P. Work is, work is 100, power is 0.5 kilowatts. My kilowatts and kilowatts cancel and I'm left with hours, 200 hours. How much power is being developed by a machine that can do 600 kilowatt hours of work in 12 hours. So that's easy, everything's in the right unit. Kilowatt hours divided by hours, and I'm going to be left with kilowatts here. It works out to be 50. To ensure that I have 2 sig figs, put a line over that last 0. So some real life power things I have, now I kind of mentioned this previously, so here's another one. A human walking, 230 watts, horse walking steadily, so there's where that 746 watts is equivalent to 1 horsepower. Average human sprinting, 1,000 watts. Top athlete sprinting, 1,700 watts, and that corresponds to 2.27 horsepower. So when you do the horsepower lab, you can kind of get an idea as to how well you will be able to generate power by running upstairs. If the top athlete can generate 2.27, chances are you'll be less than that. Power, work done per unit of time, so in joules per second or watts. And of course we could also have horsepower there too, meaning that horsepower is equal to 746 watts. And I believe that is it for the vocab for that booklet. So there you have it, that's the third booklet, dealing mostly with power, how it's calculated, the different units here of course, and also work. Can be expressed in terms of watt seconds or kilowatt hours. Okay, we'll see you next time.